Let's look real quickly at the CAM software and see what we're trying to do here. This is the first facing cut, just to rough off the face so I don't have too much stock to take with the finish tool. And then the next roughing passes to rough off the OD of that stock. This is coming straight in with the end mill parallel to the stock. And then to rough the first step over here off. And to rough behind here with a smaller end mill. Just slot out that with a trochoidal movement. And then we're going to mill this face with the end mill. Mill that notch. Finish, mill that notch. Finish, mill that step and notch behind. And then do that face. Then do the bottom face like that. And then do this face like that. And then the angular face like that. And we're going to drill the 3 holes here. They're all the same size hole, which is a tap size drill for a 1/4-20 tap. So we drill those 2 holes and then that hole through the angle you see there. Then mill this countersink. Now the reason I milled these countersinks is because the part's kind of sitting out here thin, and a countersink puts quite a bit of pressure on something when you're going down into it, and it might tend to not come out to the right size or chatter or something. So I decided to mill these with some surfacing type milling cuts like that with a small bull-nosed end mill. It's a 3/16 bull-nosed end mill. You mill that chamfer or countersink on the back there, and then a chamfer for the thread, tap drill, and tap. And then also on this side to mill a chamfer here for where that hole exits, where the tap exits. And you come back with the tap here and tap the hole, and then the parts like this, the tool comes in and parts it off. So let's look at the simulation of this. So here's the facing cut like you saw. And here's these roughing cuts. This is a it's just staying on Y0 and rotating the C-axis to make these cuts. And then here's that smaller end mill to rough out the notch in the back side of the part, if you will, or the closest to the chuck. Then the finishing tool, like you saw before, finishes the faces. Now I did it this way because it's there again, because the part is kind of flimsy sticking out here. It's only 1/4 inch thick actually, and this seemed like the best way to do it without getting chatter in the finishes. But with this big machine, it takes a little while to index those the rotary axis. It's not real fast on the C-axis rotation, and so it takes a little bit more time than it would be if you did this on say a turret lathe with milling capability. It would be actually faster than this machine could do it. So that's that. Now it says it collides with the tap because the model has a tap drill size hole, so it thinks it's colliding. And then here's the parting off operation. Right there, and then I just break it off. So that's the cam real quick, just so we can get an idea of what's going on there. I'm holding this up for the camera so you could see it, but I don't normally do it this way, so it's kind of awkward. I usually support it against the bench here when I'm doing this so that it doesn't move around on me so much. Kind of important that you use smooth movements with this grinder, and you want to do it kind of as if you're climb milling. If you try to pull it against the direction of the cut, it vibrates. So you kind of just let it flow across there as it pulls itself almost, with a very light pressure on it. Otherwise it chatters and it vibrates. So these two surfaces are going to make sure I got the smooth edge toward the part here. I can't really get the grinder in here on these edges as easy as doing it with the file like this. This is a very fine file. Remember, it's like a number Swiss, or number 4 Swiss made. It's very fine. I got these at a jewelry supply place, if I remember right. So that's the deburr part of it with that, and then I just go over it with the Scotch-Brite. Normally I have the light a lot brighter than this, but I put a piece of paper around the light because it reflects off everything. Too much for the video. So it's kind of hard for me to actually see what I'm doing too good here. I'm hitting this just very lightly with this Scotch-Brite wheel on the grinder, just to kind of take off any additional burrs. Because even if you deburr something, like if you deburred this on the machine, and I would have done that, except that with this big machine, it takes too much time. I can deburr this before the first tool finishes running on this part, and it just takes too much time. It's kind of slow in indexing the C-axis, and I even tried to turn the brake off on the C-axis, thinking that would speed that up, but it didn't really help too much in the actual machining part of the program. But if I went around this and deburred this in the machine, it would just add to the cycle time, and so I can do this while I'm while I'm running the machine on the next part, and I can check it. I usually check the this is the 1/4-20 go gauge. Check to make sure that goes in there, and then I just roughly check all these dimensions with the calipers just to make sure I haven't got something totally off here on the part. And I kind of eyeball this countersink depth. So that's the part finished. Now these parts have to be heat treated still to an H900. This is 17.4, and they have to be heat treated to H900, which I'm going to attempt to do by myself, or as myself, I should say, in a little. I have this little oven that runs on 110 volts, and I think I could stack all these in there and do them all at once. It should hold it all right. And all you have to do is heat this to 900 and hold it for, say, an hour, 900 degrees Fahrenheit that is, and hold it for about an hour, and then pull the parts out and let them air cool. It'll turn them brown, kind of like about this. This is kind of a maroon color, but it'll turn them brownish color, sort of like that when it does it. But it doesn't really scale them up any, because 900 isn't hot enough to really scale it up at all. So that's actually enough parts for the order. Actually, one extra one. So that's it for this video on making a little part on the big machine. Not the most efficient machine to do such things on, but it did it. And I had 45 of them to make, and it took a day to make them. You could probably do it faster other ways. You know, this machine takes a long time to make tool changes, and it's not efficient that way. It's designed for bigger parts to take more power and torque and everything, and so it doesn't move as fast as a smaller piece of the machine. Like the little Integrex over here that they have, the i400 moves a lot faster than this machine. In fact, I ran it once, it kind of scared me. It goes, whoa, you know, that thing rotates the C-axis quite a bit faster than this one. But anyway, I hope you enjoyed the video, and thanks for watching.